Welcome back. Now let's discuss two problems. With that we can wind up our fourth unit. The first problem is a 240 watt peak photovoltaic cell has a short circuit current of 8.99 amperes and the open circuit voltage of 36.72 volts at a temperature of 25 degrees centigrade. Calculate the change in short circuit current, open circuit voltage and maximum power when the temperature is increased to 40 degrees centigrade. Assume the temperature coefficient of current is plus 0.047 percentage per Kelvin. Temperature coefficient of voltage is minus 0.34 percentage per Kelvin and temperature coefficient of power is minus 0.7 percentage per Kelvin. Now what is that they are asking in that problem? Now let's draw the IV characteristics of a solar cell. Right, now that red characteristics and green characteristics. That red characteristics are the IV characteristics of a solar cell at 25 degrees centigrade or 25 plus 273, that is 298 Kelvin. Right, now that green color characteristic, no, let's talk about that red color characteristics first. That is the IV curve and a PV curve. Right, IV curve, what is the ISC at that 25 degrees centigrade? 8.99 as mentioned in the problem. And the other side, that is the red color curve touching the x-axis is the VOC. What is that VOC? 36.72 volts at 25 degrees centigrade. Remember that the red curve is drawn at 25 degrees centigrade. Now, and in the PV curve, what is the power? 240 watt peak. The top point in that PV curve is the 240 watt peak, which is the peak power. These are the three values which are given in the problem itself. 240 watt peak is the maximum power, 8.99 amperes is the ISC and 36.72 volts is the VOC at 25 degrees centigrade. Now they are asking us to calculate the value of ISC, VOC and PM at 40 degrees centigrade. That is, now let's draw the IV characteristics and PV characteristics of a solar cell at 40 degrees centigrade. So at 40 degrees centigrade, ISC increases. ISC is increased. ISC at 40 degrees centigrade is more than the ISC at 25 degrees centigrade. Therefore, ISC is increased. Now, what is that increase in the value of ISC at 40 degrees centigrade? We need to find out. And what about the VOC? If the temperature is increases from 25 to 40 degrees centigrade, the VOC value will decrease. Now, you can observe the green color curve over there as well as the overlap at the top. The red and green color curves will overlap. So that VOC at 40 degrees centigrade we need to find out. As well as the power also decreases. You can see the red color curve is at the top, at a bigger one, and the green color curve is at a shorter one. Right. So you can see that PM at 40 degrees centigrade we need to find out. So we need to find out ISC at 40 degrees centigrade, VOC at 40 degrees centigrade and PM at 40 degrees centigrade. For that what we have to find out? We have some formulas, right? Change in ISC, that is ISC at 40 degrees centigrade equal to ISC at 25 degrees centigrade into 1 plus alpha I delta T by 100 is the formula we have. So ISC at 40 degrees centigrade we need to find out. So what is ISC at 25 degrees centigrade? 8.99 into 1 plus alpha I. What is alpha I? That alpha I we need to take in terms of percentage there. Because there is a by 100 here, that's why we need to take it in terms of percentage. That is 0.047 percentage is nothing but the alpha I plus. Therefore, in place of alpha I am keeping 0.045 plus 0.045. And what is the temperature difference? 40 minus 25. T2 is 40 and T1 is 25. Actually speaking, I need to place 40 plus 273 minus 25 plus 273. Anyway, it's a difference. 273 will cancel with each other and that's why I am taking in the centigrade itself. That is 40 minus 25 by 100. Now if I calculate, I will get 9.05 amperes. So ISC at 25 degrees centigrade is 8.99 amperes. But ISC at 40 degrees centigrade will be more than the ISC at 25 degrees centigrade, but it's a slight increase only. That is 9.05 amperes. Next bit. Change in VOC, that is change in VOC, that is VOC at 40 degrees centigrade equal to VOC at 25 degrees centigrade into 1 plus alpha V delta T by 100. What is alpha V given in the problem? Minus 0.34. And what is VOC at 25 degrees centigrade? 36.72. Therefore, VOC at 40 degrees centigrade equal to 36.72 into 1 plus alpha V is minus 0.34 percentage per Kelvin. Therefore, minus 0.34 into delta T means 40 minus 25 by 100. Then you will get 34.874 volts. You can see there is almost 2 volts decrease in the voltage. Right. So VOC at 40 degrees centigrade is 34.874 volts. Whereas VOC at 25 degrees centigrade is 36.72 volts. The voltage is reduced by 2 volts. But what about the current? Current is increased by only how much? 0.06 amperes only. Right. Now the third one is change in power. That is PM at 40 degrees centigrade equal to PM at 25 degrees centigrade into 1 plus alpha P delta T by 100. PM at 25 degrees centigrade is 240 watt peak, which is given in the problem, and alpha P is minus 0.47 percentage per degree Kelvin. Therefore, 240 into 1 plus minus 0.47 into 40 minus 25 by 100 we will get 223 watt peak. So the power is decreased by how much? 17 watts. Right. Power decreases drastically with increase in temperature. Right. 17 watts. Voltage decreases with increase in temperature. It is 2 volts. It is decreased. Whereas the current increases slightly, only 0.06 amperes. Right. In an exam, they may ask you at whatever may be the temperature. In this, I have given a 40 degrees centigrade. Maybe in the exam, they may give you at what is the ISC at 60 degrees centigrade. What is the ISC at 50 degrees centigrade? What is the ISC at 30 degrees centigrade? In place of 40, you will keep whatever is that given in the problem. Right. It is the first problem. Now the second problem is, which is a very very important problem, which is given twice in the exams. The specifications of a solar PV panel at STC of 1000 watt per meter square, 25 degrees centigrade and AM 1.5 is given below. What is that? Module size is 119.1 centimeter into 119.1 centimeter. Module weight 7.5 kg. Cell size, the area of each cell in the solar panel 12.5 centimeter into 12.5 centimeter. Number of cells are 36. Maximum power is 80 watt peak. Maximum voltage is, that is maximum power at maximum voltage at maximum power is 17 volts. So and maximum current, that is the current at maximum power is 4.75. So if I multiply 17 into 4.75, I will get 80 watt. Right. Short circuit current is 4.9 amperes. Open circuit voltage is 21.2 volts. These are the specifications of a solar panel. Now what is that they are asking us to find out? They are asking us to draw the IV and PV curves of a solar panel and label the parameters of the panel. And then the second bit is calculate the solar cell efficiency and solar module efficiency. And third bit is calculate the fill factor of a solar module, which is a very very important problem given twice in the exams. IV and PV characteristics of a solar cell. Now we know what is the IV and PV characteristics of a solar cell. Right. Right. That red color one is a IV characteristic and the green color one is a PV characteristic. What is the ISC? 4.9 amperes. What is the VOC? 21.2 volts. We have marked those two values. What is the maximum power? 80 watt peak. And on the green color curve we have marked the 80 watt peak. Now what is the VM and IM? If I draw from the point PM, if I draw the line that is meeting the IV characteristics, and from that point if I extend it to the right, I will get the IM. It's 4.75 and VM is 17 volts. You can clearly see it. IM is less than the ISC and VM is less than the VOC. It is the first point. The second point is solar cell and solar module efficiency. Now solar cell efficiency. What is the solar cell efficiency? Output power by input power. The output power is known as the PM, whereas the input power is PI, P input, and the output power is maximum power, which is V maximum into I maximum by P input, whereas the input power is calculated as solar radiation intensity into area of the cell. Now let's calculate P input and P maximum will be given as how much? P maximum is already given in the problem itself. From the specifications, what is P maximum? 80 watt peak. Maximum power is 80 watt peak. Therefore, PM is 80. Now we need to calculate P input. P input is solar radiation intensity into area of the cell. What is the solar radiation intensity given in the problem? 1000 watt per meter square. Therefore, IS input is 1000 watt per meter square. Now we need to calculate the area of the cell. How many cells are there? 36 cells. And what is the size of each cell? 12.5 centimeter into 12.5 centimeter. Therefore, area of the cell is 36 into 12.5 centimeter into 12.5 centimeter. Now convert this 12.5 centimeter into meter. That is 1 centimeter equal to 10 to the power of minus 2 meters. Now you will get 0.125 meters into 0.125 meters into 36. Therefore, the area is 0.0156 meter square is the area of a single cell. And there are 36 cells in it, and you will get 0.561 meter square. And what is the P input now? Solar power input 1000 watt per meter square into the area of the cells in the solar panel is 0.561 meter square. Now if I multiply these two, you will get 561 watt, which is the P input. Now what is the efficiency of a solar cell? P maximum by P input into 100. What is P maximum? 80 from the specifications. What is the P input? We have calculated as 561. So 80 by 561 into 100. So the efficiency of a solar cell is 14.26%. Now the next thing is module efficiency. What is the module efficiency? P out by P input. So P out is the PM by P input. So PM is nothing but VM into IM. But what is the P input? In case of a P input, while calculating the module efficiency, P input will be solar radiation intensity into area of a module. In the previous case, while calculating the efficiency of a solar cell, I have taken the cell area. Now I have to take the module area. The module area is already given in the problem, which is as 119.1 centimeter into 119.1 centimeter. So the area of the module is 119.1 centimeter into 119.1 centimeter. Convert it in terms of meters. It is 10 to the power, multiply with 10 to the power of minus 2. That is 1.191 meters into 1.191 meters. So the area of the module is 1.418 meter square. Now what is the solar input power? 1000 watt per meter square into 1.418 meter square. Therefore it is 1418 watts is the solar input power. Now what is the I have given as a cell efficiency. Sorry, it is the module efficiency. So module efficiency will be PM by P input into 100. PM will be from the specifications 80 and P input will be 1418 into 100. You will get 5.64%. You can observe it here. The cell efficiency is 14.26, whereas the module efficiency is 5.64%. That is, here the solar module efficiency is very less compared to the solar cell efficiency. The third one is the fill factor. What is fill factor? The ratio of maximum power by theoretical power. What is the maximum power? Vmax into Imax. What is the theoretical power? VOC into ISC. What is Vmax in the problem? The Vmax in the problem is Vmax, that is the voltage at maximum power is 17 volts. Current at maximum power is 4.75 amperes. Short circuit current is 4.9 and open circuit voltage is 21.2. Now let's substitute in the equation. That is Vm Im by VOC into ISC. What is Vm? 17 volts. What is Im? 4.75 amperes. What is VOC? 21.2 volts. What is ISC? 44.9 amperes. If I calculate it, I got a value of 0.77 is the fill factor. Now the fill factor is 0.77. It is a very important problem. Practice it and you will and the same problem is given twice in the final exams. Thank you.